So, you've probably heard of prompt engineering, right? Of course you have. But here's the thing. That's quickly becoming just the starting line. Today, we're talking about what's next. This much bigger, more powerful idea called context engineering. This is about graduating from just giving the AI a command to actually designing the entire world that it sees. Okay, let's get into it. So, what's the real difference here? Well, think of it like this. Prompt engineering is simply what you say to the model. It's that one instruction. Context engineering, on the other hand, is everything else the model gets to see. This information payload, as it's called. It has examples, it has memory, it has documents, it has tools. It's the difference between asking a stranger a question on the street versus handing an expert a full briefing binder before you ask. And hey, don't just take my word for it. This term was actually coined by the AI leader Andrej Karpathy, and I love his definition. He calls it a delicate art and science. That phrase is perfect, isn't it? It captures the idea that this isn't just about cramming more data in. It's about precision. It's about carefully curating and designing the information to steer the AI exactly where you want it to go. All right, so let's move from that high-level idea and really nail down a solid definition. This will help us get a sense of just how big this discipline really is. Okay, here it is, the formal definition. And this is based on a survey of over 1,000 research papers. It's the design, orchestration, and optimization of the complete information payload. Now, the words that should jump out at you there are design, orchestration, and optimization. See, we're not just providing information anymore. We are actively building, managing, and refining it. It really is an engineering discipline. So what's actually in this payload? Well, it's a whole toolkit. It includes examples, which is how you show the model what a good output looks like. That's your few-shot learning. It includes memory, so the AI can actually remember what you talked about 5 minutes ago. There's retrieval systems to pull in real-time factual documents. You can give it tools, like a calculator it can use on its own. And you can even build in control flow to help it manage really complex, multi-step jobs. To make this all feel a bit more concrete, let's try a metaphor, a biological one. We're going to build this idea of context up from its smallest possible part into a complex, functioning system, kind of like building a living thing from scratch. So here's our roadmap. We're starting with atoms. That's the simple single prompt. Then we're going to bond those atoms together to create molecules. These are your examples and patterns. From there, we build cells, which is where memory and state come into play. And finally, we assemble all of that into organs, which are these powerful agentic systems that can do some seriously complex work. So let's start at the beginning with the atom. The atom is the fundamental unit, the basic building block. It's just a single instruction. Translate this sentence. Write a headline. This is what we all know as basic prompt engineering. It's the skill most of us have been working on. But, a single atom floating by itself isn't all that powerful. So the next step is to combine them to create molecules. Molecules are patterns that we build from examples. This is the technique called few-shot learning. So instead of just telling the AI what to do, like write a funny tweet, you're showing it 3 examples of funny tweets. And that little shift from telling to showing is a huge leap forward in getting the results you want. Okay, moving up the chain, we go from static molecules to cells. And we do that by adding one absolutely critical new ingredient: memory. A cell is what allows the AI to manage state across an entire conversation. It's what lets it remember the context of what you asked before. This is what transforms a simple question and answer bot into a stateful agent that you can actually have a real conversation with. And finally, we combine these memory-enabled cells to build our most complex structures: organs. Organs are systems designed for really sophisticated multi-step work. We're talking about agentic systems now. You might have one main orchestrator agent that manages a whole workflow. For example, it could tell one specialist agent to browse the web, another to summarize the findings, and a third to write the final report. It's like having a whole team of AI specialists working together on a project. Okay, so the biology metaphor is a nice way to wrap your head around the concept. But is it just a nice idea, or does this stuff actually work in the real world? Let's look at the data, because the impact you can measure is, well, it's pretty wild. Just look at these numbers.
Researchers at IBM Zurich tested a model on some brutally difficult math competition problems. On its own, the base GPT 4.1 model got a score of just under 27%. But when they gave it cognitive tools, which is just a fancy name for a form of engineered context, its performance shot up to over 43%. That is a massive improvement, and they didn't change the model at all. All they did was engineer its context.
And this is not some isolated fluke. Research from all the top labs, Princeton, MIT, you name it, is all pointing in the exact same direction. We're finding that LLMs can develop their own internal logic, that new kinds of memory systems let them handle these incredibly long tasks. It all converges on this one idea. The path to more powerful AI is through better context.
So, we've covered the what, we've covered the why, we've even looked at some hard evidence, but let's bring it all home. What's the practical takeaway here? Why should you care about this big shift from thinking about prompts to thinking about context? Okay, let's just connect the dots. When we use retrieval augmentation to ground an AI in facts, what happens? We cut down on hallucinations. When we build in memory systems, we get those coherent, long-form conversations we've always wanted. When we use control flow, we can suddenly solve much harder problems by breaking them into smaller steps. And as we just saw with that IBM data, giving an AI cognitive tools can unlock these deep reasoning abilities that were already there, just waiting to be used. Every piece of engineered context makes our AI systems more reliable, more capable, and just more intelligent. And that really leaves us with this one last big question. We've spent the last couple of years getting really good at crafting the atoms of AI interaction, those single prompts. But we are now entering an era where we can literally build entire universes of context. So the question is no longer just, what can we ask an AI? The real question is, what kinds of intelligent, specialized environments can we build for them to operate in? The possibilities there are just beginning to open up.